All right, so I think we will start at 3:10. All right, so if you could get a chance, fill out the survey in our chat so we can improve on this in the future. And so once again, our name is, we are Careers in STEM, and this is our seminar on engineering. So my name is Dalia.
And my name is Annika. So for those of you who are new here, and as a reminder to those who aren't, CSTEM is a nonprofit student-led STEM outreach organization. We aim to connect the classroom curriculum to real-life careers by introducing you to the various professions in the STEM field. We hope to encourage many or all of you to pursue careers in STEM.
So during the seminar, we have invited two very accomplished professionals in engineering. However, unfortunately, our other guest speaker, Mr. Hilden, was unable to come today as he got sick. So we will have just one guest speaker, Dr. Salazar. And so we will start with a short presentation and continue with a Q&A. Then through the presentation, we hope you will learn more about their job responsibilities, educational background, and useful advice you may take with you on your pursuit of similar STEM careers. If you missed this seminar or part of it, it will be recorded and available on YouTube. So stay tuned for that update on our Instagram, or fill out the survey in the chat to join our mailing list.
Our guest speaker is Dr. Andres Salazar. Andres Salazar Yunas holds a PhD in engineering from the University of Georgia and is the current senior manager of power electronics at Span.io, a San Francisco-based tech company developing products that enable homes to get clean energy faster, cheaper, and more efficiently. Previously in his career, Dr. Salazar was part of Rivian and Sun & Inc., where he led cross-functional teams in the design and development of energy systems for residential applications. Let us welcome Dr. Salazar.
Hey, Dr. Salazar, I think if you're speaking, I think you're on mute.
Sorry, I was trying to share my screen, but it says that it's not allowed.
Okay, I've just enabled controls now.
Okay, perfect. So let me see if this works. Right, can you see my screen?
Yes, we can.
Okay. To minimize this. Perfect. So, well, thank you so much for having me here today. Very glad to speak about a little bit about what has been my path through engineering. I'm a bachelor's in electronics engineering. I'm originally from Colombia, South America, and I came after graduating from my bachelor's. I came to the U.S., basically to the University of Puerto Rico, which is part of the university systems of the U.S. actually, to pursue a master's degree in electrical engineering. Back then, to be honest, I didn't know exactly what my path through engineering should be. I just knew that I want to develop products. I wanted to work on development of electronics systems or electronic products. And by doing my master's or by being there, I realized or I learned about something really cool that was solar panels, about solar energy. And I really wanted to learn more about, how a solar panel is able to capture energy from the sun and then convert that energy into electricity. That's what the solar panel, basic functionality solar panels. And I developed my work thesis and my projects in learning or in developing algorithms to control the energy that is coming from the solar, then passing through the panels to the cells in the panels, and then turning that energy into electricity, into electric energy now, and put that into a load, into a motor. That was basically how to control a motor load using solar panels. So I developed algorithms that help to control the motors, and that started my passion and my curiosity, more than passion, I would say, about how, this is cool. I mean, I want to know more. I want to grow in this path, in this career path. So I came to Georgia and I found a company called SolarMax, where I started learning more about solar. So this company developed used to develop a product that you will find in any solar plant that you will see when you're driving, in the highway and you see multiple solar panels across the highway in a very open space. Normally these solar panels, they need to have a small device called an inverter, and this inverter, what it does is basically take that energy and put it into the electricity that is coming from the panel, and put it into the utility, into the grid, into the power grid. And so this inverter was my first step, or developing this inverter was my first step of developing my whole professional career, because by being in SolarMax, I learned how to develop inverters for commercial applications, how to certify inverters, how to test inverters that were very, very high in power, and what to program or how to program inverters in order to be successfully deployed in the field. Then I moved to another company called CSTEM, which is right now, it's a German company, but it's based, it has an R&D hub here in Atlanta as well, in Stone Mountain to be more precise. And this company, what they do is to develop solar batteries. Now we're not talking now about not only solar panels, but now we're talking about solar batteries. What a solar battery do is that instead of just only produce energy when you have sun, you store the energy from the sun in a battery pack, in a battery module, and then you deploy that energy at night where you have less consumption in your house. So these solar batteries are tailored for residential applications. So you put this in your house, in your garage, and you connect, your whole electric appliances to the battery through your breaker box. So anyway, so while I was there in Sonning, I wanted to learn more about engineering, I wanted to do more research. So I went to University of Georgia. I did my PhD in parallel while working with Sonning, and I continue my research experience as well as my professional experience in the field of power electronics and inverters applications, solar energy storage, and so on. And not only that, my position at Sonnen, I became the director or manager director of the power electronic groups. Was the group or the team that created the first inverter for the company. or develop the first inverter for the company. And I had to develop skills now about leadership, about how to help other people in the team to grow as well as I grow, as the company grows as well. And later I moved to a company called Rivian, where there is a company that produces electric vehicles, electric pickups, to be more precise, and SUVs. And we were trying to do their residential energy system for using their main products, their cars. And I moved to a company where I'm working right now, which is Span, which is a startup company. We're about 200 employees right now in San Francisco. We are working on helping more into the electrification of the new revolution of energy that includes all of the, basically, that all of the energy sources that you have in your house can come out and be more harmonized by using a smart way to synchronize and optimize the energy that you produce with your solar panels that you have in your house, with your electric vehicle that you have in your house, and with all your electrical appliance. So this is what Span is doing right now, trying to help of enabling the electrification for our next, the next generation of energy consumption in the upcoming years. So let me tell you a little bit about the motivation of what I'm doing right now on the field of energy systems for residential applications. So what happened during the, when you in your house, in your when you get your electric bill, is that you have 2 periods of high consumption in your house during the day. Let's say that this is if the yellow line represents how much the sun energy produced during the whole day, and the red line is your electrical consumption in your house. I mean, how much energy your electrical appliance consumes during the day. And normally, in most of the cases, most of the electrical consumption comes during the beginning of the day and at the end of the day. So basically, when you prepare what for you going to school, and then when you come back from school, and then you have a period during the day when you have a very little electrical consumption, very little electrical consumption. So what happened? Then you figure out, okay, this is something that I can do better. I mean, I can probably lower down my utility energy bills if I use a solar panel. So that's when the people start installing solar panels in their houses. So by doing that, you can take advantage of the amount of sun that you have during the day and the amount of sun that you have by the end of the day, and lower down a little bit your electrical consumption. And of course, you can lower down the whole, if you have some consumption in the middle of the day, is when you have more sun, is when you can take more advantage about your solar panels. And later on, you start thinking, okay, what about if I, instead of using that energy, or not using that energy at the middle of the day, what about if I store that energy in a battery and then I deploy it at night and I deploy it at the beginning of the day? And that's basically what you do with a solar battery. That's what I was telling you, what I did at Sonic. So you now have in your house not only a system that can take energy from the sun and convert that energy into electricity, and then now you have a system in your house that is able to take that energy from the sun, put it in a battery, and then deploy that energy back to your house or to your electric loads in your house when you have periods of low sun production, low energy from the sun. low production from energy from the sun. What I'm doing right now, what I, in my last year of experience, is how we can incorporate new technologies that are coming in the latest in the recent years. Not only from batteries and solar, but how can we incorporate new technologies related to electric vehicles? How these can be incorporated into the residential energy system. And that's what we at the SPAN right now we're trying to do. How we can enable more people to have electrical vehicles, electrical appliance, and the consumption from those electrical appliances and the production from these sources can be controlled in a more smarter way. So that's what I'm doing right now at SPAN, and what we're doing at SPAN. So are we okay with the time so far?
Yes.
Okay, sorry. So finally, the final conclusion that I would say, I mean, for any STEM career that you decide to take in your path, in your life, I would probably advise you 5 things. First is dedication. I mean, no matter which career you choose in the STEM field, you don't need to be the smarter or the more intelligent person in the room. You need just to be dedicated. I mean, if you have dedication about what you do, if you go every day and do your homework and study hard, you will be successful no matter what. How smart, how brilliant you are, or you are not. Dedication is the first thing that you need to have in order to become a good engineer, a good professional in a science, a technology career. Commitment. You have to be committed to what you do, to the things that you choose, to the path that you have chosen for your life. No matter what it is, you need to concentrate on it. You need to stick on it. You need to be focused on it. So commitment is the second thing that I would say you need to have and you need to follow. Responsibility, you need to be responsible. I would recommend this no matter how smart or intelligent you are. If you're not responsible, nobody will like you in the professional world. I mean, if you cannot deliver your work on time, there won't be any boss that would say that can recommend you in the future. So if you're not responsible with your tasks, with your homework, forget about all the skills that you might have that are important too. Responsibility it comes as one of the main ones that you need to have. Time, I think this is comes in different flavors. Time, for me, it's not only time to manage the time. I mean, you need, in the same way that you're responsible with your tasks and with your homework, you need to be responsible with your time. There is time for everything in this life, but time to play, time to be with friends, and to do your homework. So every moment in your life is important. So, and time is the most important and non-renewable resource that we have in the life, unfortunately. And you need to be very conscious about how do you, the quality of the quality of the time that you spend on it, of the activity that you spend using your time. So be conscious about it. Time is really important. It's an important resource to have and to know and to manage. And also be patient. I would say be patient. Things sometimes we are desperate a lot about the things that are not coming in the right moment or when we want it. Things come sometimes in the moment that they need to happen. And if you are dedicated, if you're committed, if you're responsible, things will come to your life. Mentor, find a mentor Try to, no matter in which, at what level you are in your life, if you're in high school, in college, graduate, try to find a person who can guide you, who can tell you things that he or she has learned on his life, professionally, personally, that can help you to grow. And when you get that, when you get that, and if you have the opportunity also to mentor other people, do it. So it's not only about finding one; it's also about giving. Once you have it, give that back. So mentoring is important, and I highly recommend it. So if you go into the engineering path, IEEE, we in the electrical engineering and computer careers, we have an organization called IEEE. IEEE helps is an organization that you will find. I mean, if you go to a computer science or electrical engineer or electrical or computer engineering career, you will find a organization that will help you to find mentors. So, and if you, and even if you don't find, if you don't have any organization like that, you know, try to recognize the people nearby or close to you that can serve you as a mentor, and ask them if they can be your mentor. So this is really important too. Yeah, so I think this is basically my professional life in a nutshell in 15 minutes. I hope this could help you in some way, or if you have any questions, I'm open to listen and to answer.
Thank you so much, Dr. Salazar. That was very informative. So we will now be moving into the Q&A portion. So if anyone has any questions for Dr. Salazar, please put them in the meeting chat, or you can just unmute and ask them.
Okay, so one question I had myself was like, what do like the day-to-day schedule for like your job look like?
So right now, and as a manager, so it's a lot of planning, a lot of meetings, organization of work, trying to also schedule time with the team, making sure that the team follows, you know, the directions of the company, the directions of the project. So a lot of meeting, a lot of plannings, a lot of emails. It's less and less technical work, to be honest, when you become a manager. But you have to be technically knowledgeable enough to recognize what the other people in your team can do, can deliver, and understand their roles.
What would it look like for like entry level, or like once you like when you first get in as like a developer?
Yeah, so yeah, that's very interesting question. So it's a lot of learning. So of course you have to read a lot. You have to be humble and recognize that you don't know everything. I mean, sometimes when you graduate from college, you believe that you know you're the king of the world, and you can do everything. That's not most in the case. So you have to be humble enough to recognize there are people that are more knowledgeable than you are, and you need to learn from them. So there's a lot of learning that you need that needs to happen at the beginning. So reading a lot, watching a lot of YouTube videos about, to be honest, YouTube video helps a lot nowadays about doing stuff, about programming, about connecting things, dealing with test equipments and things like that. So, but but definitely reading will become big part of your daily job when you are in an entry level, and asking things as well. Asking.
Okay, another question that someone sent in the chat was, were there any other fields or products besides energy systems that you considered pursuing in the beginning of your career? If so, what made you decide to pursue solar power instead?
Yes, so in my career, so when I was in my bachelor's, my thesis project was a small it was to develop an algorithm inside of a small, it's a chip called FPGA. So in this FPGA, I developed an algorithm for satellite applications. So digital signal processing, basically, it's called the field, DSP, digital signal processing. So this has everything that has to do with, how you capture signals that are coming from your cell phone, and then reproduce those signals, put those signals into another layer of the application in your cell phone or in your satellite radio and so on. So this I was really interested on also pursuing this path, digital signal processing. However, to be honest, and this is something that it happened to me. I mean, it was, I don't know, destiny or God, or I don't know how to call it. I was traveling to Puerto Rico in the plane, and then I read an article in the plane that talked about, and that was 10 years ago. That was in 2000, more than 10 years ago, 12 years ago, 2008, about the future of the green energy industry in the United States. And I said, oh, this is interesting. I never heard about this, and but by then I was focused. I wanted to do the digital signal processing. This is what I want. I don't want anything else. And then while I was in the master, I met this professor, and this what I tell you, that it's important to find mentors, to recognize people who can mentor you, who had this group in power electronics, and he developed his main goal was to develop algorithms to control solar panels. And I started talking to him. I became really interested and started working with his group, with his students, and the rest is basically my history. What I told you, I got really interested. I got really curious about it, and that basically drove me to continue on this career path. And I've been very fortunate to also to continue this career path here in Atlanta. I mean, Atlanta is not really a city where you find a lot of industry in energy and solar, but I was very lucky to find a company that helped me to grow in this field. And yeah.
Okay, so I received another question. So how has a PhD in electrical engineering been helpful in your career? And do you think that it's important to have a PhD, or would a bachelor's or master's be sufficient?
No, I think PhD is important when you like research. When you really are in a point in your career where you want to do more research, and you want to and in some way you feel like certain professor in certain university, or what certain university is doing, it's important, and it's very interesting for you to know more, and you want really to do research. So a PhD, more than it's like a job, PhD, people see it as a education path, but it's really a job. You have to do it's like starting a new job in research, basically. So if you like research, go for a PhD. I recommend it. But find the one that you really try to find the professors that you really want to work with, and really and the things that you enjoy working in, because it's gonna be a lot of hours of reading papers, of developing in front of the computer, developing algorithms. It's a lot of time that you're gonna be sitting in front of the computer, researching and developing. So yeah, that's I think the importance of a PhD. It's not necessary. I mean, people have developed really good. I've met people in my life that without a PhD are excellent professionals. They are really good on research. They're really good on developing products. And just by having a bachelor degree and a master is like a middle step. It's like if you want to after graduating from college, you want to explore, initiate your path or have initial path into the research life. You probably start with a master's, and then after that you jump into a PhD, or you just continue with the working in the in the industry. So it's basically it's up to you. You have to decide. There is no one only path. It's basically what you feel, what you like, and what you at that moment in your life, what you think is it's gonna make the best. It's gonna be the best decision for you. But it's not. I wouldn't recommend any over the other. I mean, all the path all the path that you choose to develop your professional career is good. It all depends on you.
Okay, and then are there any skills or like courses or classes or videos online that you think students could start looking at early if they thought they might want to pursue electrical engineering in the future?
Sure. I recommend the Coursera.org. It's a good website. EDX is an excellent website with university courses from the best universities in the world. Nowadays, YouTube, it's awesome. I mean, you find you really good content from individual contributors that just want to spread their knowledge through the world without any cost. So YouTube is definitely the best resource that I can recommend. But specific websites, I recommend Coursera and EDX. They help me a lot, and I think for anyone who wants to learn extra, they will help them as well.
So one question that I had was, I've read a couple of articles talking about how sometimes making products that conserve energy use a lot of energy in of themselves. Like for example, sometimes like making electric cars would also require burning coal or burning fuel. So I was just wondering how some of the companies you've worked with have handled that.
Yeah, there's right now the companies are creating a sustainability department that is trying to focus on that, how to minimize the impact of production, and also how to recycle their products in a way that can be reutilized or part of the So one experience that I can tell you on a previous company, one of the previous companies that I worked, is that they, and even if you go to the website, Rivian is doing really good job on trying to develop their electric vehicles with recycled materials in the interiors, for instance. So trying to like, if you have a factory where you develop your products, normally in order to reduce your carbon footprint, you can install solar plants that can power or wind turbines that can power your manufacturing plant. That is another way that the companies nowadays are employing to try to reduce their carbon footprint. So yeah, I mean, but there's a whole new area on that matter. And that's why nowadays, the important thing is nowadays, most of the companies, including the very big ones, are putting a lot of efforts on trying to be more conscious about how they produce their their products, how their products can be more environmentally friendly.
Okay, and so for our final question, do you have any like final advice for high school students who are interested in STEM?
Yes, I would say, like, well, besides my 5 takeaways that I gave you, I would say be curious a lot. If I would put this question in a different way so it makes more sense to me. If I have to tell myself, 20 years ago, yeah, when I was still in high school, what you can recommend me in order to be successful in the future and in the STEM career, I would say, be conscious about the time that you spend. Spend quality time with your family, spend quality time with your friends, but also try to be conscious about the things that you can learn now. And the good things, like you said, like we were discussing before, the good things about nowadays that I didn't have that back then is the opportunities that you, by using just a phone or a computer or a small smartphone, to go to YouTube and search the things that you really want. Buy a small Arduino board. If you like electronics, for instance, in my case, if I like, I used to like electronics or developing things. So buy a small Arduino board in Amazon, go to YouTube, learn how to program an Arduino board. Or, if you're not familiar with Arduino, there's other, platforms that you can also search where you can develop, really cool things, like robots, like, a small, battery chargers, small, small electronic things, that gadgets that you can get fun with, learn and do something productive and creative, and who knows, maybe you can create your own mini Apple in the future if you do that. So that's basically the advice that I would give myself if I had the opportunity 20 years ago. So I would say the same to you. And basically, I'm more important now that you have all these cool, things where you can find so much information.
Okay, so I think that'll be our final question. Unfortunately, like we said earlier, our other guest speaker was unable to come as he is sick. So this will be the end of our seminar today. Thank you so much to Dr. Salazar for presenting. If anyone you know couldn't make it this time, we will be posting an update to our mailing list and Instagram once we have a recording uploaded on YouTube. We've also posted our last seminar's recording to our YouTube account as well at CSTEM US.
Thank you again, Dr. Salazar, and I hope everyone has a great afternoon. Thank you so much for coming.
Thank you. Thank you for having me. Bye.